All right, let's look at the two types of critical numbers. Here's an example. F of x is equal to x times cube root of x minus 3. All right. When it comes to taking the derivative, I'm not a big fan of cube root. So I'm going to rewrite it as x times quantity x minus 3 raised to the 1/3 power. All right. Before we take the derivative, I'm going to find the domain of this function f. Right? Domain of this function is going to be all real numbers, because unlike square root, cube root can handle negative values, so there's no restriction. The reason why we need to look at the domain of the function is that to be a critical number, it has to be at least inside the domain of the function. Right? But in this case, there's nothing to worry about because all real numbers are included. Right? So let's take the derivative. Right? So we're going to take the derivative using the product rule. Right? So derivative of the first, which is 1, and times the second, plus first times the derivative of the second. So put 1/3 in front. Keep the inside function as it is. And subtract 1 from the power, so 1/3 minus 1 is negative 2/3, multiply by derivative of inside, so derivative of x minus 3 is 1, so which doesn't do much, right? So let's clean it up. So once you clean it up, you're going to get something like this, right? So since the 1 doesn't do anything, so I got rid of that. Right here, x goes on top, 3 goes on the bottom. Quantity x minus 3, because of the negative power, goes on the bottom, and we still have to raise it to 2/3 power, and the 1 doesn't do anything, so we got rid of it. All right. Then in order to combine these two terms, I'm going to find the common denominator. All right. So we can multiply top and bottom of the first term by this denominator, right? So that we have a matching denominator, right? So if you clean it up, you're going to get something like this. Right? So we have the same denominator, so we put that. Right? So 3 comes from there, so that goes there. Right? X minus 3 to the 1/3 power times x minus 3 to the 2/3 power. Since 1/3 plus 2/3 is 1, so you just get the x plus 3 to the first power. Right? So you just get that. And then you have plus x. Right? Then we can clean up the numerator a little further. You're going to get something like this. Right? So we have 3x plus x, so you get 4x. 3 times negative 3 is negative 9. So this is the f prime of x. Right? Now we can find the critical number of type 1. Right? A critical number of type 1 is the number that makes the derivative equal to 0. So we're going to set this derivative equal to 0. Right? So in order to make the fraction equal to 0, all we care about is the numerator. So make sure that you get the numerator is equal to 0. Then we can add 9 to both sides. You get 4x equals 9. Then divide through by 4 to get x equals 9/4. Right? So 9/4 is a critical number of type 1. Right? How about the critical number of type 2? So those are the numbers makes the derivative undefined. Right? Where is this derivative undefined? Right? So the fraction quotient is undefined when the denominator becomes 0. So you can see that when x equals 3, denominator is 0. So f prime of 3 is, you have a 0 on the bottom, and the 4 times 3 minus 9 is 3. So 3 over 0 is definitely undefined. Therefore, x equals 3 is a critical number of type 2. So we have two critical numbers, and one is type 1, the second one is type 2. All right, now let's look at the graph of this function. So I'm going to sketch the graph of this function, right, which looks like this, right? Then, so the critical number of type 1, 9/4. Right, 9/4 is about there. And if you look at the graph at x equals 9/4, you can see that it has the horizontal tangent line, because you know that the derivative equal to 0, which means that the slope of the tangent line is 0. So therefore, we have a horizontal tangent line. All right. How about the other one, critical number of type 2? So x equals 3. You can see that the x equals 3, it has the vertical tangent line here, right? So remember that the vertical line has an undefined slope. So therefore, the derivative is undefined there. So that's why x equals 3 is the critical number of type 2. All right, that's it. I hope that this was clear.